Well, let's take a look at question 5.3.78 in the fundamental theorem of calculus section. The goal of this problem is to take the derivative of an integral with respect to t, and we're taking the derivative with respect to x evaluated from 0 to x squared. Okay, so what I've done here to try to explain the process for you is to show that whenever we integrate this function dt over t squared plus 12, I went ahead and showed whatever the integral is, it's going to be with respect to t. Okay, now we know that due to the definite limits of integration, we're going to take that integral with respect to t, but then we're going to evaluate it from 0 to x squared. And then the goal is to take the derivative with respect to x. Okay, so that I always call it a dummy variable of t. It's just a placeholder because then when you evaluate it at the limits of integration, you're going to get the antiderivative evaluated in terms of x squared minus the antiderivative evaluated with respect to 0. Now, we already know that the derivative of anything evaluated at a constant is just a constant, and that the derivative of any constant is 0. So that last part here all cancels out. So I don't even have to worry about that f of 0. It doesn't contribute to the answer. Now I need to worry about, well, what's the derivative with respect to x of the antiderivative evaluated at x squared? And here's where you have to use the logic that, well, that the derivative and the integral are inverse functions. So you're going to get back the function that's on the inside, but it's going to be evaluated at the limit of integration, that x squared there. Now, there's another step to that because the integral had no way of knowing that I would eventually evaluate it at a limit of integration that would cause a function inside of a function. So when I do the derivative later, I have to worry about the derivative chain rule. So I can say, okay, evaluate the inside function at the limit of integration. So I put the x squared in the place of t that's being squared, but then I multiply that by the derivative with respect to x of the limit of integration that I plug in. And so then my final answer, we know derivative with respect to x of x squared is 2x. My denominator after squaring the square will give me x to the fourth plus 12. And again, remember, the second term completely irrelevant because when you take the derivative with respect to x of any constant, you just get a 0. So I get final